Hello everyone, Jelani here from MWL Tutoring, and welcome to my channel that is dedicated to helping you improve and succeed at CXC Math. Now in our last video, we stopped off at this point here where we were looking at how our general form of the quadratic equation, which looks like this, ax squared plus bx plus c equal to 0, how that general form could help us in creating the graphs of our quadratic equations known as parabolas. And we saw an example here where if we look at what we have, the a number in our example 2, it's a positive value, so we have a minimum curve. And what we also saw is that the c value, which in this example is positive 1, tells us where the graph cuts through the y-axis. Now if you didn't see this before, I'll link the video just above me here so you could go back and watch it and catch up to speed. But what we're gonna go into today is the question that I left off at the end of that video. We have two graphs here, a red graph and a green graph, and both of these graphs are minimum curves and they both pass through the y-axis at positive 1. So the question I asked was, how do we know which graph is the correct graph for our question here? And the way we answer that is by looking at the graph and seeing what is different about it. Well, if we look at our two graphs, we notice that on the red graph, the values let me use a different color. Let's use yellow. The values where the graph cuts the x-axis are at a negative point. These are on the negative side of the graph because remember the center here is our origin. So to the left is the negative and to the right is positive. So on our green graph, the values of x are positive. So once we could find our values of our x-intercept, then we could essentially figure out which of these graphs will be the most appropriate one. And we went through, or I should say I went through how we do this in a previous video, and I'll put another link to that. But let's talk a little bit more about these x-intercepts and what they really mean and how we could get them. So I'll go onto a new page and we'll talk about the x-intercepts, or the more common name for these are what we call the roots of a quadratic. And the roots of these quadratics, or of any quadratic I should say, the roots of any quadratic essentially tell us the value, or values I should say, because if we jump back here, there are two values for each graph. So we should say the values of x when y is equal to 0. And we have three ways of finding the roots or the x-intercept of our quadratic. Those three ways are: 1, we could find the roots by factorization. 2, we could find it by using the quadratic formula. Or 3, we could find the roots by completing the square. And what I'll do, I'll put a little asterisk on the third one, just because we're not going to cover it in this video, because I want to give it its own separate video, as completing the square is something in its own category, and we want to look at that separate from what we're covering in this video. But it's still good to know that we could find the roots using the completing the square method if we wanted to. So for today's video, we're just going to look at factorization and quadratic formula. And I did videos on how we do these already, and I'll link them as we progress through this video. Let's start off with factorization with our same example back here. So let me just copy it. And what we're going to do, we're going to find the values of the roots or the x-intercepts to see which graph is going to be our correct graph. So what I mean by that is, let's say when we get our values for the x-intercepts, we get two positive values, then we know the green graph has to be the right answer because that's where the x values are positive. And if we get two negative answers, then we know we should use the red graph because that's where the x-intercept values or the roots are negative. So let's go onto a new page. We'll paste the question here. And like I said, I'll link the video on top here for my factorization video. In this video here, I'm just gonna go through it very briefly, but I went through it in detail in that last video, so check it out if you're not familiar with it. But what we want to do to factorize our quadratic, the same first number and last number, so this 2 and positive 1, we're gonna multiply them. So 2 by 1 is simply 2. Then we list our factors, and this is not, the factors of 2 is just 1 and 2. And what we have to do is we have to add up our factors to make sure that they add to our middle number. So our middle number is positive 3. And when we add our factors 1 by 2, so if we add 1 plus 2, we get positive 3. And now that we know this, what we want to do is we want to rewrite our quadratic. And instead of writing 3x, we're going to break it up using the factors that we just found out. So we're going to say x plus 2x, because if we add these up, we'll get 3x. And then we continue on with positive 1 equal to 0. And once we do this, we factorize by grouping. So this is our first group here. This is our second group here. And if we factorize our first group, the only thing that is common is x. And once we factorize, we get 2x plus 1. And if we factorize this group here, what is common is actually positive 1. And once we factorize, we get 2x plus 1. Now, our two brackets have the exact same value in it. So we factorize again, and we get 2x plus 1 and x plus 1 here equal to 0. So now we've finished factorizing, and we want to solve for our two values of x. So what we do, we simply take one bracket and we put it equal to 0, 2x plus 1 equal to 0, and we solve for x. So 2x will be equal to negative 1, x will be equal to negative 1 over 2. And then we take our second bracket and we put that one equal to 0. So x plus 1 equal to 0. So that means x is equal to negative 1. So what we just realized here, or what we just solved for, is we figured out our values for our x-intercept or our roots are negative 1/2 and negative 1. And if we go back across to our graph, that means negative 1/2, let's use yellow, negative 1/2 is on this side here, and negative 1 is here. So our red graph is the correct answer. So I'll just put correct here and wrong here, because now we know the values of our roots. The two values are negative, so they have to be on the left hand side of the origin. So that's how we use these values of the x-intercept or the roots to help us figure out even more about our quadratic. Now, like I said at the beginning here, we have another way we could look at finding the roots or the x-intercept, and that is by using the quadratic formula. And again, I went into detail in this in a previous video, so I will link it again. But let's just go through the quadratic formula very quickly here, so we could just see it in action and how it gives us the same roots that we just calculated using the factorization method. So this is our same quadratic here again. And this time we're going to use the quadratic formula. And the quadratic formula looks like this. It tells us that our roots, the formula for it is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And remember, at the very beginning of our first video, we said that the general setup of a quadratic equation looks like this: ax squared plus bx plus c equal to 0. So our values of a is 2, our value of b is 3, and our value of c is 1. And now we could just plug that information into our quadratic formula and solve. So minus b will be minus 3 plus or minus the square root of 3 squared minus 4 by a, which is 2, by c, which is 1, all divided by 2 by a, which is 2. And now we're just gonna crunch numbers here. So we have minus 3 plus or minus square root. 3 squared is 9, minus 4 by 2 is 8, 8 by 1 is still 8, so we have 9 minus 8 divided by 2 by 2, which is 4. And now 9 minus 8 is 1, and the square root of 1 is simply 1. So what we're ending up with is negative 3 plus or minus 1 over 4. And this is going to give us our roots. So I'm going to go onto a new page here to finalize our answers for the roots. So our roots, again, just rewriting, is equal to negative 3 plus or minus 1 over 4. And we need two values of these roots, because we got in the last question, when we did it by factorizing, we got negative 1/2 and negative 1 as two values. So what we're going to do is we're going to separate this plus or minus sign in the middle up here. We're going to separate it to get our two values. So we're going to say our first value is going to be negative 3 plus 1 over 4. And our second value will be negative 3 minus 1 over 4. So negative 3 plus 1 is negative 2 over 4, which could reduce to negative 1/2. And negative 3 minus 1 is negative 4 over 4, which could reduce to negative 1. And there you have it. We've gotten the same values of our roots as we did when we factorized, which proves that we could use the quadratic formula or the factorization method to solve for our x-intercept or roots of our quadratic equations. And just lastly, just to recap why we did all of this in the first place, if I just go back to our graph, the reason we did all of this in the first place is because there were two graphs that looked like they could be the answer to our question here. And what was the main defining characteristic, or what separated these two graphs, were really the values of the x-intercepts. Because when we did our calculation, we got negative values for our x-intercepts, which meant that the red graph had to be the correct answer. Because the green graph, the values of the x-intercepts, although we don't know what they are, they have to be positive because they lie to the right of our origin. So that's just the reason why we find the x-intercepts, or the roots of the quadratic equation. There are many other reasons why, but this is just a fundamental video just to explain the brief breakdown of it. And yeah, so that brings us to an end of this video here. If you found it helpful or enjoyable or whatever, just give it a like if you want to support. And if you want to see more videos like these, consider subscribing to the channel. I believe I have one more video in this fundamental series where we go through completing the square. And yeah, so once again, thanks for watching, and I'll see you in the next video.